Hello again, everybody. So today we are watching a video that demonstrates how to create a sequence operation between a linear and a rotary actuator using a sequence valve. So this is our HPU. I have a pump that runs at 250 RPM, has an internal volume of 3-inch cubed per revolution. I set the relief valve at relatively high pressure, so fluid do not tend to go through the relief valve, rather travels mostly through the circuit. Using a DCV, which has an open center condition, which is also called a motor spool. I have connected one linear cylinder and one hydraulic motor. So that's our rotary actuator. Because of this, I have chosen to use the motor spool in the DCV. So I want to create a sequence between A and B. So in a way that A extends and B waits until the extension is done, and then pressure rises on the other branch. And with that increased pressure, I want to operate pilot the sequence, open it, and then eventually run the motor B. So that's the idea. So we have to set certain pressure at the spring of the sequence valve so we can create a delay corresponding to that spring tension. The other necessary values are all written. One thing I want to highlight here, if you are watching this video for lab 2, you are not supposed to do anything using Automation Studio for the reporting. Unlike lab 1, where we needed to do the simulation for the circuit and then compare the results, in this one, we are not required to compare the simulation results. This is only for your understanding. Hopefully that is clear. The other thing I want to, I think worth mentioning is the T fittings. You can see wherever I have 3 pipes connected in one point, I have chosen to use a T fitting rather than just putting them, connecting them simply in Automation Studio. I did not do that for a very good reason. So I also suggest that if you are choosing to do the simulation to practice before you actually go to the lab, you also want to use the T fittings instead of just connecting the 3-way pipes in one point. The T fittings in its bare form, so if I just take it out, you see it has 3-way ports. Each of these ports should be connected to each of these 3 open lines. Okay. Also here, same thing is going to happen. I also chose to have measuring instruments. This one will measure the rotational speed, RPM, of the motor. So let's begin with the normal simulation. I can see that there is a flow happening in this part of the HPU, which is almost 2 gallons per minute. You can set different flow rates here. In order to get exactly 2 in the line, maybe you should choose 2.02 in here, so then you can get 2 gallons per minute. All the fluid is doing a loop now because of the position of the DCV, of course. And I have chosen to set a spring tension of 0. I want to show you, if I don't set any spring tension here, the sequence valve actually acts like a normal open pipe. So then there will be no sequence between A and B. Once I move to this position, both A and B should start extending. That means in a linear cylinder, it should start moving. And in the rotary cylinder, extension would mean it will start spinning at certain RPM. So let's watch. And you see that happens. In the beginning, it was a little bit slow because, of course, the total flow was divided into 2. But once the extension was complete, all the fluid now traveling in this part, in this branch, and that gives it a boost of speed. So let me do that again. Every time I switch the DCV, I want to use the center position as a stopping block and then move. You see during retraction also, both are doing at the same time, because there is no real sequence here. So they start at the same time. So let's watch a couple more times. You have to see whether the A and B are moving at the same time or there's a delay. So they're moving basically at the same time. During retraction, also they're moving at the same time. This is because I did not put any resistance in the sequence for the pilot to work on. So now I'm going to put significant value, 200 psi pressure needs to be created on this upstream side, which will then pilot this spool open, and then only the motor can run. And that will happen when this branch has a lot of pressure. And that is possible when extension is fully done. All the fluid on this branch it gets stuck, and 100% fluid should travel in this line alone. That will be enough pressure on this line to work the pilot and open the spool and eventually open start the turning of the motor. During retraction, however, fluid will travel from the pump via this line, go to the rod side of the cylinder and this side of the motor, and eventually you see the fluid. If the fluid can flow back to the tank, you will see some rotation, otherwise you will not be able to see any rotations. So I'm going to check that out in 3, 2, 1. Did you watch the sequence? Let's watch it again. When I click this box, you see this one will extend, but this one will stay put because it doesn't have sufficient fluid to do the extension. In 3, 2, 1, here we go. You see it waits and then starts spinning at full speed, which is 231 at 2 GPM. And you can see the sequence valve is open, so it keeps on turning the motor. Now, if I want to retract, we want to see if there's a sequence during retraction and if there's a rotation on this one. There's a clear sequence, but it rotates initially, but then it stops because you see in the line, there is no fluid flow happening. All the fluid is flowing here only. There is no fluid flow here because the fluid coming from here, but it doesn't have a place to go back to. So if the fluid cannot continuously flow in this branch, then the motor does not spin. So during retraction, it is interesting to watch that if I set a certain resistance here during retraction, the motor doesn't do anything, only the cylinder retracts. Okay, so watch again. Extension, there's a clear sequence. Retraction happens to this one only. It initially retracts, but then it stops. It doesn't do like continuously. That happens when we extend. It happens continuously. It goes on and on. So if I set even higher pressure for the sequence, we expect the delay between the two extension or the two motions to increase a little bit because they're all in milliseconds. It's hard to tell, but theoretically speaking, the delay between the two extensions should be prolonged. Retraction. This spins a few times, but at very low speed, but then it stops because the fluid gets stuck here. Extension. There's a clear sequence. Now full extension is happening here, and then only the motor starts spinning. So pretty much that's it. You have to watch carefully the gauge pressures because the gauge pressure mean a lot. You have to ask a question in the experiment. So learn to set up the circuit in Automation Studio. Try to understand the behavior of all the different components, and then do the experiment hands-on in the lab. Hopefully, your concept will be clear before you go to the lab. That will help you immensely if you wanted to perform the lab on your own and understand it properly. Hopefully this was helpful for understanding the concept behind this lab too. And I want to see you all in the lab class this Friday. Thank you very much. Have a good day. Bye-bye.